Good morning, everyone. How are you guys today? Good. Um, I was thinking about quiz tomorrow, and then I decided, well, I'm not going to give you quiz tomorrow. I'm going to give you quiz on Monday instead of tomorrow. Okay? So no quiz tomorrow. It will be Monday, and next week Thursday you're going to have your exam too. Any other comments? So chapter 3. You're doing chapter 3, 4, right? So chapter 3, homework due Monday midnight. And I posted the notes just now. Half of chapter 4. I'm going to give you half of chapter 4 notes later, another day. Yeah, no quiz tomorrow. Instead, it will be on Monday. Okay, any question before we start? Any comments, concern, complaint? Okay, then let's refresh our memory with the last question we did in our last class. It says find the exact value of 5 trig functions for the angle that satisfies the given two conditions. The first condition is sine is 0.8 and it lies on quadrant 2. So let's draw our angle on quadrant 2. Angle always start from the origin. It has to touch either a positive or negative x-axis. So here we have an angle. So we have a triangle. And in this triangle, we have sine is 0.8. 0.8 looks weird, right? What can we do with this 0.8? Great, we can rewrite this. Sine of the angle is 8/10. Now, sine is what over what in terms of triangle? Opposite our hypotenuse. So this is opposite from this angle 8, and this is hypotenuse here 10. Now we have two sides of our triangle. Can you find the missing side of the triangle? How can we find it? By the Pythagorean theorem. So either you can do complete work like a square plus b square equals c square and then solve for that, or just to know that whatever we have here, this is the hypotenuse square minus the side square. So this is simply 10 square minus 8 square and then take the square root. Is the shortcut. Always subtract one side from the hypotenuse. So subtract the side square from the hypotenuse square. And if you take the square root, that's the answer. This is the shortcut. So I didn't change color. So we have 100 minus 64. And how much is 100 minus 64? 36. And what is square root of 36? 6. So this missing side is 6. Now the question is, on the second quadrant, which is positive, which is negative between x and y? X is negative, y is positive. So the AQC, does it represent the y value or the x value? Y. So y is positive. We're not going to change the sign. How about the 6? Is 6 x value or the y value? X value. So what sign must 6 have? Negative. So always first find the missing side of a triangle and then decide the sign. What sign you have for the two sides, for the x value and for the y value? X-axis. Okay, now let's find the rest 5. Sine is given, so let's start with cosine. Cosine is what? What over what in terms of triangle? adjacent over hypotenuse. So here this will be what over what? From our angle, -6/10. And then we have sine, cosine, tangent. Tangent is what over what? In terms of triangle. Opposite over adjacent. So from this triangle, what is opposite? 8, and adjacent? -6. So you just have to find 3 of them, and then the rest 3 comes automatically. Ten is hypotenuse. It's the radius. The radius is always positive. Okay, so we know sine, cosine, tangent. So that means we have cosecant, secant, and cotangent. Oh, sorry, it's tan and not x. So who can tell me the cosecant? What will be the cosecant of the angle? 10/8. It's opposite. It's the reciprocal of sine. So whatever we have for sine, flip it, it becomes cosecant. Who can tell me secant? So we have cosine here. If flip, it becomes secant. We have 10/-6. Gabriela, the last one. -6/8. You just flip tangent, it becomes cotangent. So yep, you're going to see this in your exam and also in the final exam. One of the 3 value will be given. You have to find the other 5 value for other 5 Trig functions. Almost half. Any other question? We must reduce, but I'm too lazy. You always have to reduce everything. You have to. So these are the answer for the reduced version. And now we are coming back to reference angle again. So yesterday we discussed reference angle. Do you remember that? Remember I said there are 4 conditions to be reference angle. What's condition number 1? It has to touch the x-axis. Either positive or negative, it doesn't matter. It must be on the x-axis. What's the second condition? Terminal side. It has to touch the terminal side of your given angle. The third condition. It's always positive. And the fourth condition must be what? Less than 90 degrees. So there are 4 conditions to be reference angle. Now, how do you find reference angle? It's based on your quadrant. So if you have anything on the first quadrant, that is the reference angle. It doesn't change. If you have anything on the second quadrant, you have to subtract your angle from 180 or 2 pi. Sorry, 180 or pi. Because here we have 180 degree, which is equivalent to pi. So anytime you have your angle on the second quadrant, you just subtract your angle from 180 and you get reference angle. But if you have anything on the third quadrant, then we have 180 here, which is equivalent to 1 pi. So in order to find the reference angle, you're going to subtract 180 from your angle. And lastly, if you have anything on the fourth quadrant, you just have to subtract your angle from the 360. If the angles are in standard position, means they are positive angle. If they are negative, then you add P60 first to get the positive angle, the coterminal angle, and then use this method. Okay, so for negative, it's better to be safe by adding 260, 360 or 2 pi, and then find the coterminal angle and then the reference angle. Okay, let's do some example. Find all these reference angles. We have 20 degree. What's the reference angle for 20 degree? 20 degree. It's already less than 0, less than 90 degree. It's already positive, and it's already touching the x-axis. So if you want to draw, come on, I just started. I have to restart. Give me 1 second. Refresh. So if you draw the 20 degree, it starts from here, its terminal side is here, and this is 20 degree. Okay, next, 135 degree. Let's draw it first. Here. So you're going to start from the positive x-axis. And 135 degree, is it less than 90 degree or more than 90 degree? More than 90 degree. Great. Now we have 90 degree here, and then 180 degree here. So 135, is it less than 180 or more than 180? Less than 180. So it's somewhere here. This is 135 degree. So it's in the second quadrant. So what would be our reference angle? 180 minus 135. And how much you get? 45. So reference angle is 45 degree, which is here, the green one. That is the difference between 180 degree and the terminal side. Okay, next one. Let's draw it fast to visualize. You don't have to draw. I'm drawing it because I want to show you what's happening here. So we have 90, 180, 270. So this is 0 degree and also 360 degree. Now 240 degree between which two 90 degrees? Between, definitely more than 180, right? Is it more than 270? No. So in which quadrant we have 240? Third quadrant. Somewhere here. So this black one is 240 degree. So what will be our reference angle for 240? So 240 minus 180 is 60 degree. So this is our reference angle, which is from here to here, 60 degree. You see all these reference angles, they are less than 90 degree and they're always touching the x-axis. Okay, the last one. Let's draw to visualize clearly. So we have 0, 90, 180, 270, and then we come back to 360. 295. It lies on which quadrant? Fourth quadrant. So we start our journey from 0 degree. We cross 90, 180, 270, and somewhere here we have 295 degrees. So for this one, what is our reference angle? 360 minus 295, 65. So we have 65 degrees, which is this tiny angle here from positive x-axis and the terminal side of the angle. It's easy, right? Not bad. That's because we know our degree. We can easily visualize our degree on our unit circle. But what if we have something in radian, not in degree? There are two ways of doing it. Change it to degree and then work with that. And then you have to change back your radian, because once, whatever format they give you, you have to give the answer in that format. So on the left page, they give us degree. Our answer was in degree format. On the right page, you have to give your answer not in degree format, but in radian format. So you can convert into degree and then find reference angle, convert the reference angle into radian. That's one method, which is a little bit longer. And the second method, you're going to use logic. So we have negative pi over 3. Now, negative pi over 3, first of all, for reference angle, let me see, what did I say here? Informal method, add pi or 2 pi, whichever is closer to the angle, then ignore the negative sign. Okay. So let's see, does it work here? We have negative pi over 3, and it's closer to which one? 1 pi or 2 pi? Pi over 3, closer to 1 pi. So add 1 pi. So the shortest way of adding these things is you multiply denominator with your constant, and then you combine the numerator. So basically we have minus pi plus 3 pi divided by 3. So what do you have? Minus pi plus 3 pi, 2 pi over 3. So this is our reference angle, 2 pi over 3. LCD, right? So what I did, instead of doing all the LCD thingy, I did everything mentally. So you multiply 3 over 3. So you get 3 pi divided by 3, and then you combine 1 plus 1 pi plus 3 pi, and then you have divided by common denominator 3. So instead of doing all these things, the shortest method is multiply the denominator with your thing you multiply, and then you combine the result with the numerator. So 3 times pi is 3 pi, and you're minusing 1. So 3 pi minus 1 pi gives you 2 pi. Okay. So that's the reference angle. And then for the next one, we have 5 pi over 4 minus 5 pi over 4, which is closer to, if you want, you can think this way. This is closer to 4 pi over 4. 5 pi is closer to 4 pi, right? So if 5 pi is closer to 4 pi, so add 4 pi over 4. So you have minus 5 plus 1, minus 5 pi plus 4 pi. How many pi do you have? On the numerator, negative pi over 4. So our reference angle is positive pi over 4. Ignore the negative sign, because reference angle must be positive. This is the shortest method. The formal method is you're going to add 2 pi, always with the negative sign, with a negative angle. And then from there, you're going to either subtract 1 pi or subtract 2 pi. That's the formal method. But you don't have to know the formal method because we have a shortcut. Just add whatever is closest to your angle. Either 1 pi, 1 pi or 2 pi to be closest. Whichever is closest, add that and then ignore the negative sign if you have a negative sign. For example, the first one, when we added 1 pi, it was positive already, so you didn't have to ignore the negative sign. But in the second one, when we added 1 pi, we have a negative sign, so you have to ignore the negative sign. So this one is actually what you can think is this. This thing is closer to 3 pi over 3. Basically 1 pi, because the 3 cancel out. What? Like all these examples are negative. But if it was positive, then you're going to subtract. That's right. Either you add a pi or 2 pi, or you subtract a pi or 2 pi. It depends. We have a negative, so you have to add. If it's positive, you're going to subtract. Okay, 11 pi over 6. It's closer to how many pi over 6? 12 pi over 6. So let me actually put them in a different place. No. It should be page break. Come on. Here. Okay, so if you have 11 pi, that means it's closer to 12 pi. So you're going to add 11 pi over 6 given, you're going to add 12 pi over 6, which is 2 pi. So how many pi we have? 1 pi over 6. And it's already positive, so we don't have to worry about the negative sign. That's our angle. Is anybody confused? Anyone? It will be either 1 pi or 2 pi. Now we decide. So the first one, we add 1 pi. The first example. Pi over 3 is closer to 1 pi. Right? Because it's less than 1. It's 1/3 of a pi. So 1/3 of a pi is closer to 1 pi or closer to 2 pi. I mean, it's closer to 1 pi, right? So you can think this is 3 pi over 3 because we have the same denominator. Now for the next one, we have 5 pi over 4. So it's 1 pi plus 1/4 pi, right? 5 means you have 1 and then 1/4. So this is closer to 1 pi or 2 pi. If 1 and 1/4, is it closer to 1 or closer to 2? Closer to 1. So that's why we use 1 pi, which is 4 pi over 4. So that I think is the number on the top. It's closer to which one? It's closer to, based on the denominator, which one you're going to get. So we have 5, it's closer to 4. Our denominator is 4. So it's 4 pi over 4. Then the 11 is closer to 12. And 12 is twice 6. So it's 2 pi. So 12 pi over 6. So first you decide, if you don't know which pi, just plug in the numerator based on the denominator. For example, here, 11 over 6 is definitely closer to 12 over 6. So you add 12 over 6. This 12 over 6, if you cancel the 6 and 12, it's 2 pi. So it's either 1 pi or 2 pi. This is 1 pi, this is 1 pi, this one is 2 pi. Now this one, negative 2/3 pi. So 2 pi is definitely closer to 3 pi. 3 pi over 3. So we have negative 2 pi over 3, and it's closer to 3 pi over 3. So what is our answer? Pi over 3. So if you take the relationship, if you look at the relationship between 2 and 3, this 2 is how many? This 2 pi is how many pi closer to this 3? Right? This 11 pi is how many units closer to something with 6? So 11 is next number, 12 is twice 6. 3, 2 is closer to 3, it's 1 times 3. So this number will be definitely a multiple of the denominator, and it's 1 time or 2 times of the denominator. Okay, so all of these are between 0 to 360, either positive or negative. Now we have something so big, 840. What do you think we should do for 840? Keep subtracting 360. We want to get an angle that is smaller than 360. So we subtract 360 once, minus 360. 0 minus 0 is 0. 14 minus 6 is 8. How much? 480. Is it smaller than 360? That means you have to subtract one more time. Minus 360. So 0 minus 0 is 0. 8 minus 6 is 2. 4 minus 3 is 1. 120. Now we like it. It's smaller than 360. 120 lies between which two quadrantal angles? It's on the second quadrant. So if it's on the second quadrant, it's here, 180 degree. So 120 degree. So what would be our reference angle? 180 minus 120, which is 60. This one. So if you have a big number, big angle, keep subtracting 360. If it's given in radian format, keep subtracting 2 pi. Keep subtract until you have something that is smaller than 360 degree or 2 pi, and then you decide how much you need to add, how many pi's or how many degree measurements. Okay, the last one, 945. What do we do? 720. Why did you pick 720? 360 times 2. So if you already know your 36 times 2, 36 times 3, then you can try that. Or if you don't know, you can keep subtracting 360. It's up to you. So let me go with 360 because most people don't know. It's 720. 545. 585. Then we need to do one more time. 225. Do you stop here or do you keep subtracting? Or you stop because it's less than 360. So 225, it lies on which quadrant? Third quadrant. So here. So what is our reference angle? We subtract 180 from 225 and we get 45. So from here to here, this is our reference angle, 45 degree on the third quadrant. Or maybe I should do it in the next. .45 degree. You may wonder, why do we care about reference angle? Well, we care because What if they ask you to find sine 945 or cosine 945 or tangent 945 or other view of 945 or 840 or all these angles? If they ask you to find them, let's find 945 for sine. If someone asks you find sine 945 degree, how you are going to find it? Is the reference angle. So we know our reference angle here is 45 degree. So from here to here, it's 45 degree. So if you make a triangle here, which type of triangle we have? Remember the two special triangles I told you? 45, 45, 90. So I don't have space. Let me write here. This is 45, this is 45, and this is 90. Now, do you remember the length for 45, 45, 90? The side lengths of the triangle? You start with 1 always. Which angle is smaller, the 45 or the 90? 45. So 45 sides length must be what? 1 or something else? 1. The smallest angle always gets the 1. That's the rule. Smallest angle will get 1. So that means this side must be 1 and this side must be 1. Let me use my angle. Otherwise we'll get confused. We have two same sides and we know they have to have the same number because they have the same angle. So 45, the opposite of 45 is 1. The opposite of other 45 is 1. And then how much is the hypotenuse? 2, because you add 1 plus 1, 2. But then you have to take square root. Because it's a Pythagorean theorem. A square plus b square equals c square. You have to have a square root somewhere. So hypotenuse gets a square root. For 30, 60, 90, for example, this one, 60. So for 60 degree, we have a triangle here. This is 60 degree. That means this tiny angle here must be 30 degree. Now for between 30, 60, and 90, which angle is the smallest angle? 30. So the opposite side of the 30 degree must be what? The length for the opposite side of the 30 degree? 1. Remember, smallest angle always gets 1. So this is our smallest angle. So its opposite side is here. This must be 1. Now the largest number is which one? 90. So this is our 90. So the opposite of 90 is the hypotenuse. That must be the next number. And now for 60 degree, what do? You add 2 plus 1, 3. You always add 2 plus 1, 3. And then you have to be inside the square root. Yeah. This is our 90 degree here. So its opposite is 2. So basically you do 2 square minus 1 square. So 4 minus 1 is 3, take the square root. We can use a square plus b square equals c square. For the 45 degree, so this is 1 and this is 1, right? A square plus b square is 1 square plus 1 square. It is c square. So 1 square plus 1 square is 2. And then take the square root, which is square root of 2. So anytime, anywhere you have a reference angle, you draw a triangle. And all these reference angles, most of the time, they will be either 30, 60, 90 or 45, 45, 90. So sine 945. So if this is our angle here, then you have to decide your sine. Okay. So on the third quadrant, what is our x value, positive or negative? I'm talking about the 945. Our x value is negative here. And how about the y value? Is it negative or positive? Negative. So we have a triangle 45, 45, 90 on the third quadrant. So x is negative, y is negative. And now sine 45, 945. So sine is what over what in terms of triangle? Opposite of our hypotenuse. So from our angle here, which side is opposite? From this angle, this is our opposite, -1. And how much is our hypotenuse? Square root 2. So see, it doesn't matter what angle they throw to us, they give us, we can always find its value using reference angles. That's why we care about reference angles. Any question? Do I have more examples? Let's see. Okay, so two methods. I told you the shortcut and I told you the formal. So the informal method, I said just add how many you have, either 1 pi or 2 pi, and then ignore the sign. The formal method says whatever angle you have, always add 2 pi first. So we have negative pi over 3, and you add 2 pi. When you add 2 pi, you get 3 times 2, 6. 6 minus 1, 5 pi over 3. Now this 5 pi over 3 is closest but less than how many pi? 1 pi or 2 pi? 5 over 3, is it close to 1 or close to 2? Close to 2. So that's why you're going to subtract this from 2 pi. So the hardest one is figuring out which one is closest, 1 or 2. If you can figure that out, then it's easy. 5 pi over 3 is closest to 2 pi, so you're going to subtract the 5 pi over 3 from the 2 pi. You always add or subtract 2 pi first, and then you subtract or add depending on your, no, first you add the 2 pi, and then you always subtract your angle from either 1 pi or from 2 pi. That's the rule. And then find your reference angle and then convert this back into radian. Of course, this is actually what I used to do. But only this semester I learned, well, let's work with radian and see what happens. Okay, for the next one, we have 11 pi over 6. Now 11 over 6, is it close to 1 or close to 2? 11 over 6. Close to 2, it's close to 12 over 6. Right? 11 over 6 is close to 12 over 6. 12 over 6 is 2. So, first you add 2 pi, no matter what, you always add 2 pi. And then whatever you have, if this is less than 90 degree, always, if it's already less than 90 degree or less than pi over 2, you keep it. If it's more than pi over 2, it's subtract that from 1 pi or 2 pi. When you added the 2 pi, we got pi over 6. Is pi over 6 less than pi over 2 or more than pi over 2? Less than pi over 2. The bigger the denominator, the smaller the number is. So pi over 2, 2 is a small number. Pi over 6 is a big number. So obviously 6 must be smaller than 2 of the denominator. So since this is already smaller than pi over 2, that's our answer. All the reference angle must be less than pi over 2 for 90 degrees. If you already have a 90 degree less than 90 degree angle, it is it. The negative 2 pi over 3, since it's negative, you're going to add 2 pi, the formal method. You're going to add 2 pi, it becomes 4 pi over 3. Now this 4 over 3 is equal to 1 or close to 2? 4 over 3. close to 1. So you're going to subtract 1 pi from your angle. Whatever number you have, either 1 or 2. You only care about 1 or 2. That's it. 3, 4, 5 doesn't matter. Only 1 or 2. Your number is close to which one? Close to 1 or close to 2? If it's close to 1, you work with 1 pi. If it's close to 2, you work with 2 pi. Let me do the more examples. I believe.
So how come it works the same way before? Except for the last one, -2 pi, we added
We give you 3 pi over 3, which are to be about. So,
yeah, but I mean, we have the same answer, but that means we can,
3 pi over 3, which is 1 pi. If we cancel out the 3, what do you have?
so we're talking about
The last one, right? So the red one is informal method. In the informal method, I said, well, all we have to do is look at it's next to how many pi, 1 pi or 2 pi. So 2 pi over 3 is equals to 3 pi over 3. So you add 3 pi over 3, and that's the answer. That's the informal method. Informal method says, well, don't work with negative sign. Always convert your negative sign to positive sign by taking the coterminal angle, by adding 2 pi, and then work with the positive angle. Let's do a few more examples. Sine 225 degrees. Let's do this. Let's try this, and then we are going to do a few examples together, and then you're going to do the right thing. Yeah. Find how much is sine 225. Okay. So step 1, find the reference angle. So if visualization makes it easier for you, draw this 225 degree if it helps you. So this is 90 degree, this is 180 degree, 225 is somewhere here. 225 degree. So we need the reference angle here. What is the reference angle for 225 degree? 45. So you subtract 180 degree from 225, and we get the reference angle here, which is 45 degree. That's step 1. You do 225 minus 180, you get 45. Step 2, decide the side length for your triangle. First, find the angle, make a triangle out of that, and then decide the length for each side. So we have 45, 45, 90. What's the length for the opposite side of the 45 degree? 1. And what's the length for the x-axis here? 1. So we have 1 unit here, 1 unit here. So what is our hypotenuse? It's 2 under the radical. And then you decide the sign for your angles. So not angle, for your side. On the third quadrant, your x, is it positive or negative? Negative. So it's -1. On the third quadrant, your y value, is it positive or negative? So it's -1. And then you find your angle. Sine is what over what in terms of triangle? Opposite over hypotenuse. -1 over square root of 2. So from this 45 degree, our opposite is -1, our hypotenuse is -2. 1 over
why so 1.
on the third quadrant, Or white's one or white's negative? Which one? White's one. We have two special triangles. One is 45, 45, 90, and one is 30, 60, 90. Now, in 45, 45, 90, the opposite of your 45 angle is 1 always. So it's a right triangle. So if this length is 1, this length is 1, you add their square, take the square root to the hypotenuse. So these are always true. It doesn't matter where your angle is lying. The opposite of 45 will always be 1, and the hypotenuse will always be -2. For 30, 60, 90, the opposite of 30 degree, the side of the opposite of 30 degree must be 1. The opposite of 90 degree, the hypotenuse must be 2. And then the opposite of 60 degree must be square root of 2 plus 1, 3. So that's it to memorize if you want to use 30, 60, 90. No. So two special triangles are only for 30, 60, and 45. And for the rest, how do you memorize the 0 degree, the 90 degree? I taught that yesterday. Okay, so without using calculator, sine 225 degree is -1 over square root of 2. Because you rationalize. We don't want the radical on the denominator. So people multiply numerator and denominator by square root of 2. So you have 1 over square root of 2. When you rationalize, it turns into square root of -2 over 2. They're same thing. Do you remember rationalizing from your 1030? So both of them are correct. Okay, now pi. We have no idea what is pi over 6, right? So you have two choices, convert into degree and then figure that out, or use the reference angle I told you. So 1 pi over 6 is closer to how many pi over 6? 1 pi over 6 is close to how many pi over 6? 6 pi over 6. So negative pi over 6, you add 6 pi over 6. That's your reference angle. What is 1 pi minus 6 pi? 5 pi over 6. Well, we have no idea what is 5 pi over 6 anyway, right? So that reference angle doesn't help us here. It does help us. No, it doesn't. First, you have to remember your 30, 60, 90. How can I make it easier for you? Maybe you should just memorize that 30 degree is pi over 6. 60 degree is pi over 3. And 45 degree is pi over 4. If you memorize these three without converting, then you don't have to keep converting your radian to degree every time. And then, it's also quick.
To 180 over 5.
True. Wait, say it again, 180 what? Yeah. I actually prefer converting my radian into degree so that I can see what's happening. So this is same as cosine negative how many degree? 30 degree. And now it's easy to visualize, right? On which quadrant we have a negative 30 degree? Fourth quadrant. It's negative, so you're going to go downward from your x-axis. Negative 30 degree. So what type of triangle we have? Which one? 30, 60, 90. So if this is 30, this one must be 60. Go ahead. I have no idea why it's 5 pi over 6. Yeah, but I have no idea in the quadrant plane. If you can visualize, it's up to you. But I can't actually visualize 5 pi over 6. Right? Can you visualize? No. 5 pi over 6. So I'll go with my degree, okay? When you find the value for your trig function, it's better to convert into degree. But if they only ask for the reference angle, you don't have to convert into degree. Because you're not looking for where the position is, you're just finding how much degree you have or how much radian you have. But when you evaluate your evaluate your trig function, then you need the position of your triangle. Otherwise, the sign will remain stuck. So in the fourth quadrant, or before that, what's the opposite of 30 degree? 1. So this length is 1. Based on the fourth quadrant, so y value must be negative. So this is -1. Oh, I should write it nicely. This length must be -1 because our y is negative. Okay, so opposite of 30 is 1. Then how much is our hypotenuse? Here, 2. And then lastly, the opposite of 60 degree is the x-axis. How much is the x-axis? Square root of 3. And is square root of 3 positive or negative? Positive, because it's a positive sign. Okay, so now based on this, what is cosine here? So adjacent is square root of 3, and our hypotenuse is 2. The answer is 3 over 2. Hypotenuse. Opposite of 30 degree is 1. Opposite of 90 degree is 2. Opposite of 30 degree is 1. Opposite of 90 degree is 2. Always opposite of 90 degree is 2. Whether you have a 30, 60, 90 or 45, 45, 90. So this is 30, 60, 90. And if this is 45, 45, 90. The opposite of 90 degree is always 2. This one is always 2. Now, one of them gets square root, the other one doesn't get the square root. So it depends. The opposite of 45 is 1, 1. Square root of 1 is 1, so it doesn't work here. That means this one must get the square root. Mm-hmm. The opposite of 30 degrees is 1. Hypotenuse is always 2. And then 60 gets the square root. For 45, opposite of 45 is 1 and 90 is 2. But this time, these 2 get the square root. Because square root of 1 doesn't make sense. The square root of 1 is 1. Remember, hypotenuse is always 2. In one of them, it gets a square root. The other one, it doesn't get the square root. 45 gives a square root. 30 doesn't get a square root. So that's why here we have opposite of 30 degrees 1. But since the y-axis on the fourth quadrant, it must be -1. Opposite of 90 degrees, the hypotenuse is 2. And then you add 2 plus 1, you get 3 after the square root. Now let's do one with big pi, 11 pi over 6. Let's do this together, and then the rest, you can work with your neighbors. So 11 pi over 6. I have no idea why 11 pi over 6. Well, actually, if you want to work with your radian And if you know, you remember this, then you don't have to convert this into degree. Let me show you both methods. Let me show you the harder one first, working with radian. So let me get a page. We have 11 pi over 6. Let's find the reference angle first. Reference angle. Now 11 pi over 6 is closer to how many pi over 6? 1 pi over 6 or 12 pi over 6? 12 pi over 6. So we are going to subtract 12 pi over 6. So what do we get? 11 pi over 6 minus 12 pi over 6 is negative pi over 6. Now pi over 6 is how many degree? 30 degree. So if you have negative 30 degree, on which quadrant you have? Let me do it here actually, not too long, not too big. So negative means it's going downward here, and it's pi over 6 somewhere here. So this is our 30 degree, because we know this is negative 30 degree. And then you do the same thing what we did before. The opposite of 30 degree is 1, but since it's in the fourth quadrant, it must be negative 1. How much is the opposite of 90 degree, the hypotenuse? 2, but this time for 30 degree, it has to get the square root. In 30 degree, it gets the square root. So no, the other way around, 45 get the square root. So you have 1 and 2 we decided, and then you add 2 plus 1 is 3, and the 3 gets the square root. So hypotenuse. So this is 1 square, hypotenuse is 2 square, right? So it's 2 square minus 1 square under the square root, because we have a square plus b square equals c square. So our a is c square minus b square. So c is 2 square minus b is 1 square. So you get 4 minus 1 under the square root, which is radical to under the square root. So let's say ignore the negative sign.
Ignore it, but you still needed to know where the triangle is.
For reference angle, the answer is pi over 6. But we need that pi over 6, its position. On which quadrant we have that pi over 6? It's on the fourth quadrant. That's why it's negative. Now in the fourth quadrant, our y is negative, x is positive. So cotangent. Cotangent is what over what? Adjacent over opposite. Cotangent 11 pi over 6. It's adjacent over opposite. So from this angle, our adjacent is root 3. And our opposite is negative 1, which is negative square root of 3. So yeah, instead of converting at the beginning, you can convert at the end from radians to degree. Or you can do the other way around. You can convert at the beginning and then work with the reference angle. So if you convert at the beginning, the second method. We have 11 pi over 6. We have no idea its position. So we are going to convert this into a degree. So since you want to cancel the radian, we have to put radian here. And then 180 on the top. That's the conversion factor, 11 over pi. Sorry, 180 over pi. Then 6 goes to 180 30 times. You multiply 30 and 11, we get 330 degree. So 330 degrees here. 330. So we look for this tiny reference angle here. 360 minus 330 gives us 30 degree here on the first quadrant. And then the rest, Okay. Any question? No, all the angles without using calculator, all the angles must be 30, 45, and 60. And the quadrantal angle means 0 degree, 90 degree, 180 degree, 270 degree, and then you come back to 360 degree. This is 60 degree here. If one of them is 30, other one must be 60 because we have 90 degree, the right triangle. There is no quiz tomorrow. I'm going to give you the quiz Monday. Okay, so you already did this one. So you have 5 more. Work with the rest 5. Try to find out these. And these also will be in the final exam. So definitely they'll be in the in-class exam. You didn't have to work alone. Talk with your neighbor, chat, and then figure out what could be the easier method for you. Converting to degree first, and then find the reference, or first find the reference and convert this into degree. What do you mean this? All the reference angles usually are those. Either memorize or convert. You can always convert, you don't have to memorize anything. So we have these for reference angle, these for triangles, and then the other quadrantal, 5 quadrantal angles. 0, 90, 180, 270, 360.
All rough rectangle.
We are given, which one was given? Pi over 6 is given. So you find the reference angle and then find the length. It's same. So negative means in the 4th quadrant. Positive means in the 1st quadrant. Okay, so enjoy your reference angles and evaluating Trig. I will be back. Okay, it's here. I actually forgot to mention something, is that if it's close to 1 pi, the reference angle, that means its position must be on the second quadrant or third quadrant. If it's closer to 2 pi, it means it's on the fourth quadrant or the first quadrant.
The other question. So I know when you find like the reference angle is 45, you know it's 45, 30 or 60. And what if it's 90? Then what type of triangle?
You don't use any triangle. You just take the value. Remember the quadrantal angles? Y-axis, x-axis, so 0 degree, 90 degree, 180 degree, 270 degree, and we come back to 360 degree, right? Now, this is unit circle. So for 1 unit, what's the x value here? X is 1, y is 0. So the value we have here is 1, 0. And how about the point here? X is 0, Y is 1. And how about the point here? -1, 0. And the point here? 0, -1. For quadrantal, you don't need any triangles because you have the number. Now, for example, if you're looking for, let's say, sine 180 degree. Sine means what? X or the Y? Y. So what's the Y value in 180 degree? 0. So the answer is 0. So not 0 degree, 0. Now let's say they are looking for cosecant. 180. Let's say you want cosecant 180 degree. The cosecant is what over what? The identity. It's for the triangle, but we don't have any triangle here. So based on the sine cosine, the identity, the reciprocal identity, cosecant is 1 over what function? 1 over sine. 1 over sine, which is 1 over y. So what do you have? Your y value is 0 here, right? So 1 over 0 doesn't exist. So if you know your x and y, you know all 6 trig functions. So for quadrantal, you don't need any triangle. We only need triangles for 30, 45, and 60.
So what the reference angle for 180 is?
The reference for 180 is 180. If it's closer to 180, you subtract from 180. Oh, 180 minus 180 is 0.
0.
There is no triangle. For quadrantal angles, there is no triangle. Cosecant doesn't exist because the denominator is 0. How about I tell you cotangent? What is cotangent 180? Cotangent is 1 over tangent, or there is another identity. Remember, tangent is sine over cosine. So what is cotangent? Cosine over sine. Now cos represent what? X, and sine represents y. So we have -1 over 0. Doesn't exist.
So 180 everything.
Not really. Whatever you have, the denominator is y, it doesn't exist. For example, what is tangent secant? Sorry, not tangent secant, what I'm saying. Secant 180. Secant is 1 over which function? Cosine. So 1 over x. So what do you have x value here at 180? -1. So what is secant 180? -1. If you don't have a triangle, you have to relate your angle with your x and y, means sine and cosine. Whatever angle they give you, relate that with sine and cosine. For example, cotangent, we try to work with tangent, but there is no tangent given to us. So we use not the tangent identity, but the cosine over sine identity. So actually, quadrantal angles are the easiest angles, easiest thing to work with. Tangent is sine over cosine, means y over x. That's tangent. Okay, so, so we add or subtract pi or 2 pi because that tells us the position. If we add or subtract pi, that means either the second quadrant or third quadrant. If you add and subtract 2 pi, it means the first quadrant or the fourth quadrant. Negative means you're starting from you're going clockwise. Give me an example. Cosecant. Cosecant 3 pi over 2. Okay. So we have okay, so 3 pi over 2. Let's do everything. 3 pi over 2. Now, if you want to work with reference angle, let's do that. Reference angle. We have 3 pi over 2. Is it closer to how many pi over 2? 2 pi over 2. So 2 pi over 2, is it 2 pi over 2? Is it smaller than 3 pi over 2 or bigger than 3 pi over 2? Smaller than. So you're going to subtract 2 pi over 2 from 3 pi over 2. So how many pi over 2 we have? Pi over 2, it's 90 degrees. Sure. 3 pi over 2 times pi on the bottom, 180 on the top. Pi's cancel out. 2 goes to 180 90 times. We get 270. So this is 270. That means we don't need any triangle. We already know the answer. In this quadrant, in this angle, how much is the x value? 0. And how much is the y value? -1. Now cosecant. By using sine and cosine, it's 1 over what? 1 over sine means 1 over y. So based on this, what do you get? 1 over -1. So what is our final answer? -1. Okay, I see. So this is the thing is happening. If you can remember your quadrantal angles with their radians, then you don't need to work with reference from the beginning. For example, here, 0 degree is 0 radian. 360 degree is 2 pi. This one is 90 degree, which is same as pi over 2. This one is 180 degree, which is same as pi. This one is 270 degree, which is same as 3 pi over 2. So if you at least know these 5 angles in radian form, and the 3 angles from 30, 60, 90, you don't have to keep converting everything into back and forth, back and forth. So first decide, what do you want to work with? Do you want to work with radian or do you want to stick with the degree? What do you think is easier to work with, radian or the degree? Degree. So do you all want to stick with degree and forget about radians? This is what I did all my life. So this is my first time. I said, well, no, I don't want to keep avoiding radians. So let's work with radians and see. I'm also lost. So let's go back to my original method. Convert everything into degree and work from there. So this one is -1. How did we find out? Based on our degree. 270 degrees. So you look at x and y value and relate the cosecant either with x or y. And it's no, it's related to y, not with x. Simple. Now for the next one, we have -135 degrees. Right? Negative means you're working clockwise. Cosecant.
How do you know
Degree.
1/-1?
Because cosecant is 1 over sine. What is sine here? -1. So it's 1 over -1, which is -1. So all those value we are trying to find for trig function, they are either based on x or based on y. Okay, if you're working with quadrantal angles. And if you have a triangle that you work with, then you have two choices, 30, 60, 90 or 45, 45, 90. These are the only two triangles you have to work with. So true triangles or quadrantal angles. That's it. It's all about trigonometry. Now, -135. Negative means you're walking clockwise, not counterclockwise. So let's walk counterclockwise. Our x, y, we start our journey from 0 degree, we go 90 degree, and then we go more. It's definitely less than 180, right? So we stop here. This is -135 degree. That means you're looking for this reference angle, which we are going to make into a triangle. So how much is this tiny angle here? 45, how do you know? So we did 180 minus 35, 135, 180. So we get, this is 30 degree. That means which triangle we are going to work with? Sorry, 45. Man, what's wrong with me? Sorry. 45. So the triangle we are going to work with is 45, 45, 90. That means you need to know the length of your sides. What's the opposite of 45 degrees? 1. So this is 1. Let me erase my 45 degree here. And let's write it here. 180 minus 135 is 45 degree. So this length is 1, this length is 1. And how much is the hypotenuse? Square root 2. Then you decide the sign for your x and y. What sign we have for x here? Negative. And what sign we have for y here? Negative. So they both are negative. And now we can find any angle in this triangle. They're asking for sine. Sine is what over what in terms of triangle? Because we have a triangle. Opposite. Sine is opposite of our hypotenuse. So here, which side is opposite? -1. And what is our hypotenuse? Square root of 2. So this is the answer for sine -135. So find reference angle. If possible, draw it. Decide your x and y, and that's it. If you have a triangle, you work with triangle. If you don't have a triangle, like quadrantal angles, then you only work with x value and y value. Okay, the next one, cosine 390 degrees. Is it more than 60 degrees, 360, or less than 360? More than 60. So let's draw our triangle. From here to here is 360. And then how much more we have to go to get 390? So 390 minus 360, we get 30. So this angle here is 30 degrees. So we have 30, 60, 90. What's the opposite of the 30 degree? 1. The hypotenuse is 2. And our x value is square root of 3. In the first quadrant, everything is positive. So we can find cosine directly. Cosine is in terms of triangle. What over what? Adjacent over hypotenuse. So how much is the adjacent from our angle? Square root of 3. And how much is our hypotenuse? 2. Hypotenuse is 2. Adjacent is square root of 3. To the next one, tangent pi. Pi, do you get a triangle from pi? No, because it's a quadrantal angle. So you only look at xy. Negative pi means negative 180. You are moving here, negative pi. So what's the x value and y value here? Negative 1 is x and y is y. This is x-axis, right? So this is negative 1 and this is our y value is 0 on the x-axis. So tangent is what over what in terms of x and y. Not in terms of triangle. We don't have a triangle. In terms of x and y, it's y over x because it's sine over cosine. So our y is 0, x is negative 1. What's the answer for tangent negative 180? 0. But if they ask you cotangent negative 180, DNA. Cotangent negative 180 is cosine over sine. Cosine is 1 negative, sine is 0, so it doesn't exist. Any questions so far? So 7 pi over 6. Black. Secant 7 pi over 6. Let's convert 7 pi over 6. Pi over 180. Pi cancel out. 6 goes to 180 how many times? 30 times. And we have 7 times this 30. Huh? 210. So let's draw 210. 210 degree lies on which quadrant? Third quadrant. So 180, 210, somewhere here. So are you going to subtract 210 from 180 or 180 from 210? This is 180, right? So we're going to subtract 210 and 180. And how much we get? This tiny reference angle, 30 degree. So from here to here, this is 30 degree. So let's make a triangle for 30 degree. What's the opposite of 30 degree? 1. the hypotenuse is 2. That means the opposite of 60 degree must be square root of 3. We also need to decide the sign for each length. What is the x value here? Positive or negative? Negative. What's the y value here? Negative. And now, since we have a triangle, we are going to relate secant with triangle. Secant is what over what? In terms of triangle. It's 1 over cosine. And then cosine is sine over. So this is adjacent on the bottom and hypotenuse on the top. It's opposite of cosine. If cosine is adjacent over hypotenuse, secant must be hypotenuse over cosine. So in this triangle, how much is our hypotenuse? 2. And how much is the adjacent? Negative square root of 3. And if they want the rationalized answer, your MyMathLab, sorry, I have a sign, then you multiply numerator and denominator by square root of 3. So you get 2 square root of 3 divided by 3. They are same. But personally, I don't care. Actually, they are. See on the topic at the beginning here, the title is in green, means every question you see, they all are important. No, instead of putting everything green, because all of these are green. So I just put a title as a green. Means everything under this title must be important. So yeah, definitely this will be in the final exam. At least 1, and sometimes probably 2. But in my exam, I'm going to give you 4 at least. 4 quadrants, 4 questions. Definitely. Oh, actually not 4, not 1. They give 3 of these in the exam. 3 in the final.
Same format like this, they just tell you
Find, evaluate this trig function, and then they give you all of this cosecant, cotangent, secant, those things. And if they're nice enough, they'll give you only sine, cosine, tangent. It's weird. Usually they work with these weird ones. So we don't have to worry about. Right. Always work with degree. We decided. No more radians. I hate radians. That's because I don't find them. Okay, so let me check. We have negative 2 over 3. Then we got 0, correct. Then root 3 over 2, correct. And then negative 1 over root 2, correct. And then we have root 3, yep. And then the first one is negative 1. Is it? Yep, negative 1. So yeah, everything we did is correct. Great. Okay, time is it 27? Oh, 107. Next, we're going to do the same thing, but this time we don't have 30, 60, 90 angles, those things. We have just normal, whatever is given to us. So let's say we are given the length for an angle that is not from 30, 60, 90, or 45. Well, it doesn't matter. We're going to follow the same rule what we did so far. What's the reference angle for this one? The reference angle must lie here, right? From here to here, right? These are reference angles for the given angle theta. Now they gave us the coordinate point here. What is this first number represents? the x value, the second number represents y value. So we can make a triangle here. They're telling us in this triangle, the x value here is negative 20 over 29. The y value we have here is 21 over 29. That means what is missing? Hypotenuse. Is there any way you can find the hypotenuse based on the triangles? Based on the sides? What do? You add their squares. Remember, A, B, and this is C. So A square plus B square equals C square. So C should be square root of negative 20 over 29 square plus 21 over 29 square. And then we find out how much is that. Let's do the math here. Inside blank page. Negative 20 square over 29 square plus 21 square over 29 square under the square root. The first one is easy, 400. I know this. And then this is 29 square. You don't have to find that because you are going to combine the numerator anyway. How about 21 square? 1 times 1 is 1. 2 times 2 is 4. And then we have 2 times 1, 3. Is it? Check, is this correct? 1 square is 1, 2 square is 4, and then 4, 4, 4, 4, 4. I was trying to do it mentally, but it didn't work. I missed the middle spot. And then we have 29 square. So we add 400 plus 441. We get 841 over 29 square. And what is 841 under the square root? How much? The numerator. $29. So 841 under the square root. 29 square under the square root. So 29 over 29. Really? Okay, probably because unit circle. So C equals 1. Yeah. So they really give us the unit circle. I think it's a random circle. No. They gave us unit circle. Exactly. So you really have to find it. And then you're like, well, they should have just told me this is a unit circle. So you have to worry about the radius. So this is always one thing. They didn't mention anything about the unit circle. That means you have to find all three sides of each triangle. Surprisingly, the hypotenuse is 1. That means this is a unit circle.
Just wondering, what was that coordinates right now? That is given and the x and y value on one part.
I couldn't guess. They're technically 1 unit, 70 nanometer. Does it always work? I don't know. We can actually check. Just a side track, okay? Just a little sidetrack to verify your logic, your idea. Let's say we are given 6/9 and 8/9. They are. Oh, sorry, 7. Let's say 6/9 and 7/9. So what do you get? 36 plus 49/9. 6 plus 9 is 15. 4 plus 40 is 8/9. No, it's not unit circle. So, yeah, close. Okay, anyway, so we found that all these things, let me erase to make things clearer. We have 1 here. And now let's find all 6 trig functions based on our triangle. Okay, let me call someone one by one. Diego, start with you. What is sine of the theta for this angle, for this picture? Sine is in terms of triangle, what over what? You were here yesterday, right? Remember the expression I said, so, ka, to, opposite of our hypotenuse. So opposite and hypotenuse. From this angle, how much is it opposite? 21/29, and you are dividing by 1. Oh, I can just put 1 here. Okay. So the answer is itself 21/29. Or this is y value. Oh yeah, come on, what's wrong with me? It's unit cycle, so simply take y. That's it. We don't care about finding anything. Cosine is the x. So how much is the cosine here? -20/29. Okay, neva, tangent. So tangent is y/x, right? So we have to do math now. Our y is 21/29. We are dividing by -20/29. Keep, change, flip. That cancel the 29. So the answer should be -21/20. Maybe I should get a page here to do the math. Actually, I don't. Because once you have sine, cosine, tangent, that's it. Here the rest three. Right. Cosecant must be. It's same, just flip it. 29/21. It's opposite of sine. Okay, let me get a page here to show you the tangent inside my page. So we have tangent is y/x. Our y value is 21/29. Over means divide 21/29. When you work with fraction, you keep, change, flip. So you get 21/29 times 29/21 on the bottom. 29 cancel out. Oh, 20. Wait. 20. So 29 cancel out, we get -21/20. And once you have these three, you have know the rest. Arif, secant. What would be the secant of the theta here? -29/-20. Perfect. It's the opposite of cosine. Kimberly, the last one, cotangent. It's the other, yeah. 21 divided by 29. Okay, and then what do you get from here? Over 29 times 29/21. You cancel the 29. 21. And it's same as tangent, but the flipped version. -20/21. So for any triangle without having 30, 60, or 45 angles, we can still find all these trig values by only look at x and y. I have no idea. Yeah. They told me to learn math, I learned it, and I have no idea what. Okay, like, why do you learn this? I don't know. And what sign tell us? I have no idea. I know sine and cosine, they are related to vibration. So anytime you um, do something, it creates a vibration, right? That vibration is related to sine and cosine function. But what tangent does, or cotangent, or the rest, no idea. What do you mean? Oh, we are so thinking about the real life. I forgot what you're talking about. Let me listen it nicely. This is -21 and 20. Okay, any question on this? Okay, then one exam question. Based on the triangles information, find all 6 trig functions. And are you guys doing the homework? Make sure to do them because you need practice. The information you're learning here, how much you understood. You test yourself with the homework. And now it's cold. Okay, let's see who is here today. Lysia is here, Hector B here, Marco here, Joanna here, Gabriela M here, Naiva here, Hector G here, Faria here, Arif here, Malvina here, Gabriela G here, Mia here, Diego here, Tristan here. Ramsot here. Rachel here. Julia is still sick. Fabia here. Angela here. Isabella here. Steven here. Brian here. Sihan absent, and Kimberly here. Oh, only 2 absent. Wow. No wonder class looks full today. Ready? Okay, Isabella, what is our first step? We are looking for C. How do you find C? Tens square, not plus, it should be minus, because you're subtracting from the hypotenuse. Anytime hypotenuse is given and you're finding the length of the other sides, is subtraction. And to find the hypotenuse, we add the 2 sides. Okay, so we have 100 minus 9, which is square root of 91, right? So see here the missing piece. Go ahead. Sorry, A. I mean A. A equals this. A square is 3, B square is missing, or A is missing, B is 3, and C is 10. Okay, great. Good job. Isabella, would you like to give me the sign here? Opposite our hypotenuse. Square root of 91 over 10. Perfect. Malvina, the other one, cosine. So adjacent our hypotenuse, 3 over 10. Faria, tangent. So it's opposite our adjacent. Say it again, what did you say? Square root of 91 over 3. Great. Mia, cosecant. Ten over square root of 91. You can simply take this in reverse version. Hector B. Not G, B. Secant. Say it again. 10 over 3. Perfect. You take this and you flip it. Professor, the last one, cotangent. 3 over square root of 91. Great. Good job, guys. Any question? Okay. Now the same thing, but 3 minutes. Okay, we can move it for now. You did so much today, so no problem. But I can bring it last Thursday or next Thursday? Yes, tomorrow. Tomorrow. So you'll be late or you'll be absent? Which one? No, I'll be late. We're trying to make it, but we're meeting.